previous video, we have discussed about the part A, 15 marks question, which is having 15 MCQ, each carries 1 mark. So in the part A, again it is having second part, which carries the 5 marks. Okay, each question is having 1 marks. Okay, so the second part of this part A is fill in the blanks by choosing appropriate answer from the given in the bracket. So already they have given the answer here. Just you have to choose the appropriate answer. So the first they have given like NAND, KMAP, binary demorgans and decoder. Okay. So dash is used to simplify the Boolean expression graphically. So graphically means what? We are going to use the table. That's nothing but the KMAP. Okay. So KMAP is the appropriate answer. Second is dash is logic gates are known as the universal gate. So NAND is the correct answer. Next, dash number system uses zeros and ones. Already they have given here bracket. So binary it's a uses zeros and ones. Dash again theorem relates and or with nor and. Okay. So De Morgan's theorem it uses the and or. Next question, decoder is used to convert binary code into decimal output. Okay. See, in this second part already they have given the here answer. So don't lose this 5 marks here. Okay. Use the appropriate answer to fill the correct answer. Okay. So next we'll move to the part B of this section. Again it carries total 10 marks. You have to answer any 5 questions. Each carries 2 marks. Okay. So the first question is define binary number system. So mine means what? Just you have to write it as it represents or number system which is having the base it is 2, and that method that uses only two digits 0 and 1. So each digit in this system is called a bit, like 0, 1. This is called as what? A bit. And it mainly forms the core language of the computer. Okay. So only they have asked define. So before going to define, just give one small example that that uh, the assignment or anyone who is checking your paper, he or she totally understand that whether the student is known correct answer or not. So just give the answer. The number 0 is 0. 1 is represented as 1 and again 2 is represented as 1 0. This is like a truth table, or you can give any other example of the binary numbers. Okay, like 9 is represented as 1 0 0 1. So here I have given 2 represented as 1 0. 3 is represented as 1 1 in the binary form. Okay. So 1 mark for this or 1 mark for this. They will distribute. Okay. Next, write the truth table for AND gate. Okay. So here they have asked truth table for AND gate. So only writing the truth table it's not sufficient. Okay. So you have to draw the symbol of the AND gate. You have to write the equation y is equal to AB and write the correct truth table. Okay, then only you will get the 2 marks complete. Okay, if you write the truth table wrong, your marks will get cut. Okay, so in this truth table, just write the symbol, draw the symbol of AND gate. Again, give the combination of AB 0 0 0 1 1 0 and 1 1 and write the correct output. Okay, so we will get the full correct 2 marks. And don't forget to write the equation, logical equation. Okay. So next third question is what is 2's complement? Give one example. Okay. So 2's complement it's a mathematical method which is used in the computers to represent the signed integers like whether it is positive or negative. Okay. So it allows the hardware to perform both addition and subtraction using the same basic circuits. Okay. So here we can represent in the 2's complement 0 means what? It's a positive and 1 is for the here negative. So we can give one example. This is the main definition of the 2's complement which is mainly used to represent the signed integer positive or negative and 0. Okay, and it is mainly performed for what? Both addition and subtraction using the basic circuits. Okay. Now write the example. Just represent one decimal number with the binary number. Here I am taking the example of the 5. So 5 it is represented using the binary as 0101. And one's complement, you all know the method of how to find the two's complement. So two's complement uh, method is, first we have to calculate the ones complement plus 1 we have to add it. Then only it will get the two's complement. That means what? We are going to represent the negative number of the 5. Okay. So that's why it is called as twos. So first, before going to this, first find the ones complement of 5. So wherever 0, replace it with the 1. Okay. And 1, wherever is 1, replace it with the 0. So 0, 1, 1, 0 is here. Okay. And what about the two's complement of this? First, we have to collect the ones complement of this 5 number, 1010 plus 1. So add with the binary addition law. Okay. So 0 plus 1, 1. So 1 as it is here, again 0 here and 1. So total will get the 1011. This is the main two's complement of the 5 number. That means we are representing the negative 5. Are you getting? Okay. So this example, correct example will carry 1 marks and definition will carry 1 mark. Okay. So next question, define, stop and pause. So in the sum of product, SOP means what? It's a sum of product and pause is product of sum. So where we are using this, these are the standard methods for expressing the simplifying Boolean logic equation in a digital circuit. Okay. So SOP, it's an equation where individual product of terms, that is, first you have to remember product of terms, that is ANDed with the OR. Okay. ANDed variables are summed together. Okay. So the name itself, it indicates that it's a sum of the product. That means plus, this is the sum of the product, like A into B bar. Okay. This is, I am giving one example here. So these are the example of the proper standard sum of product. Okay. Next. Product of sum, this is an equation where individual sum term like A plus B bar. Sum terms, it is odd with or multiplied and added together. Okay. So A plus B bar dot A bar plus B bar plus A plus B. Means what? It is a product is in the outside. Okay. And sum it is in the inside. Okay. So just define this and give one example of the proper both equations. Okay. Next, mention any two applications of multiplexer. So mux are used in what? Adder, subtractor, data selection, data communication, etc. Next question, write two features of the gray code. So gray code mainly used in the unit distance property like unweighted code, reflecting property, cyclic property, anything. Next question is state any two Boolean laws. Okay. So Boolean laws are known as AND laws, OR laws, commutative law, distributive law, and many other are there. So just you have to mention state. Okay. So each having the half marks, total writing any 4, you will give the 2 marks. Okay. You can give any 2 examples also. Okay. Next. Define half adder. So half adder is a what? Adder is a what? Combinational logic circuit with the 2 inputs and 2 outputs. And which are the 2 inputs? Just mention. The 2 inputs A and B which carries output as sum and carry. Okay. And this combinational logic circuit which is designed to add, how many numbers we can add? 2 binary digits. Okay. 2 binary digits. And this is called as what? Half adder. And that produces the output along with the carry value. Okay. So this is what the part B of the question, which is having the 10 marks. Okay. So you have to solve any of these 5 and each carries 2 marks. Next we'll move to the part C of this question paper and you have to answer any 5 questions. Okay. Which is having the 15 marks. So each carries the 3 marks. So first question is what? Convert 255 decimal to a binary number. So first of all, we have to any number which is converted to decimal to binary, we should write the divide by to the particular number. So 255 divided by 2. How much will get? Like 2 ones are 2, again 2 twos are 4, again 2 sevens are 14. So we'll get the base as remainder as 1. Again 127 divided by 2, we'll get the 63. 63 twos are 126, 127. Again we'll get the remainder as 1. Again divided by 2, 31 I'll get. Again we'll get the remainder as 1. These are the odd numbers. That's why we'll get the remainder as 1. Okay. So at the last you have to again 1 divided by 2 you have to write. And at the last you have to collect all the ones which is having the 1 1 1 1. Okay. So in the calculator also you can verify it. Okay. In the calculator, we are having the different binary, hexadecimal, octal number. So you just write the decimal number and convert it into the binary, whether your number it is correct or not. Okay. So for this division and correct answer, you'll get the 3 marks. Next, explain with the diagram the operation of NOT and NOR gate. Okay. So with the diagram means what? NOT gate, you have to draw the symbol, logical equation, and again truth table. Okay. So what is the equation for NOT gate? It is a bar. So wherever 0, you will get the output as 1. 1 it is there, output is 0. Next is what? NOR gate. NOR gate, draw the symbol of the NOR gate, write the truth table properly. Okay. It is exactly the opposite of the OR gate. So write the explanation. Just don't write the any symbol and truth table. Just you have to explain those in the small sentences like NOT gate. It is also known as what? Inverter. And it is a basic digital logic circuit that has how many inputs? Mention it. One input, one output. And how it receives input signal? Meaning the high output. High input 1. Just mention the truth table in the sentence. Okay. Whatever you learn in the truth table, write it in the sentence. Whenever the input it is 0, I'll get the output as 1. And when the input is 1, the output produces the 0. Okay. And write the logical equation of this NOT gate is equal to A bar. Okay. What about the NOR gate now? A NOR gate is a digital logic circuit that yields high output 1 only when both inputs are 0. Okay. See, from this truth table you can write the whole explanation. If any one of the input is high, still the output is 0. Okay. Next. And the equation of this phi is equal to a plus b whole bar. Okay. Next question. Derive 1's complement and 2's complement of the given number. So they are given some this number 1010 and this. So we have to derive. First we have to derive 1's number. First write down the given number first. So this is my given number 101010. This is the given number. Okay. 1's complement of this, all you know that once wherever 1 is there, replace it with the 0. 0 replace it with 1. Okay. So this will become the 1's complement. And 2's complement equation is what? 1's plus 1. Okay. So 0, 1, 0, this is 1's. Plus 1 we have to add. Okay. Plus 1 we have to add. And after adding this, I'll get the answer as this. 0, 1, 0, 1, 1, 0. Okay. So mention the number here. Add according to the Boolean laws. Okay. Next question is write standards. Okay. What is my next question is write standards of expression for A, B, C. And they have given the numbers as summation 1, 3, 4, and 6. Okay. So to write the standards of form means what? The every term should contains the A, B, and C. That is called as what? Standards of form. Okay. So I given this easiest method for you. First, you just write the ABC as a truth table like 0 to 7 up to. Okay. So start from your decimal number like 0 to 7. Okay. So wherever this table is easy for you to write this. Okay. Here I am writing the decimal numbers. And what about the output? So as here mentioned the summation, that means the output of these numbers will be 1. Okay. So wherever 1, 3, 4, 6 are there, that output will be 1. So here it is 1. So I am writing output here as 1. 3 is there, output is 1. Again 4, 1. 6 output is 1. And what about the standards of form of this? So output is 1. That means I have to take A means what? Representing 0. A bar, B bar, and C is the positive. C is this. So output will be A bar, B bar, C. Next is the 0, 1, 1 means what? A bar, B, C. Again 1, 0, 0. Wherever I have shown with the red color, that output shows the standards of form. So here A, B bar, and C bar. Last one is the A, B, and C bar. So now collect these all ABC standards form and write with the proper F equation. Okay. So the complete will get the 3 marks here. Next, explain the need and applications of the logical families. What is the need of this logical family? Logic family is the basic main need to the building any digital circuits. Okay. So it is mainly standardized for the electrical characters like voltage levels, operational parameters. Okay. So digital ICs, again communication, work together reliably. Okay. So what is the need? First one is the standardized performance. Each family here offers with what? Speed, power, and voltage level. And second need is offer design flexibility. So it provides trade-off between the speed, power consumption, and cost. And support flexibility. Logic family helps in building the complex digital circuits like microprocessors and memory unit. Next question. Next one is the common logic family, which is having the TTL. These are the classification like TTL, CMOS, and ACL. These are the main logic gates. Okay. Based on this, we can design this logic family. So application of these logic families are CMOS, TTL, and ECL. And where they are used, CMOS it is mostly used in the digital ICs like microprocessor, microcontroller, memory chips, RAM, ROM. Again, portable devices like in the laptop, the main you say motherboard, which ICs contains that all based on the CMOS techniques. Okay. Next, it is the TTL. TTL it's used for the oscilloscope, logic analyzer, function generator, again old control panels, many more. Okay. And ECL it is used in the high performance maintenance mainframe systems like supercomputer data cards, again telecommunication, which we have to send the high frequency clock distribution and many more. Okay. So these are the some theory part. Next question. Next question is the draw the truth table and block diagram of the 2 to 4 binary decoder. Okay. So 2 to 4 it's a binary decoder. You have to write the block diagram first. 2 to 4 the name itself indicates 2 means 2 inputs you have to write. Give the 2 inputs and 4 is these are the 4 outputs Q0, Q1, Q2 and Q3. Okay. And you have to write the truth table. Okay. So based on the this communication, okay, Q0, Q1, Q2 and Q3, these are the my 4 outputs. So when does this Q0 will select? From this truth table you can see when the input is 0, 0. Okay. If I took this input as 0, 0, So that time it will select the Q0. Okay. Next. So remember this one is like your TV remote. Okay. Suppose your Ashtak TV channel, it is based on some number like 256 number. So whenever you add the 256 number, automatically you will get the Ashtak channel. Okay. So suppose you select the 111 channel for TV9. Okay. So that time it will select the Q1 another channel like this. Okay. So here if I make the 00 combination, it will do the select the output as the Q0. Again 01 if I do, I'll select the Q1. So like this Q2 and Q3. So based on this, the equation will be like logical diagram for this. This is Q0, Q1, Q2. So Q0 it was A, B both are 00. That means we have to represent this as the A bar and B bar. And in between those two, we have to select the AND gate. Okay. Q0 is equal to what? A bar B bar. Q1 is A bar B. Again Q2 is A B bar. And last is Q3 is the A into B. Okay. So this is the simple. You can remember this. First you have to remember the truth table. And from the truth table you can write the block diagram. Again compare analog and digital circuits signals. Sorry. Analog and digital signals. Many are there. So analog signal, it's a continuous signal. Again, it's a troubleshooting difficult. Okay. So I have given this theory. We will go through the next question. Simplify the A bar BC plus ABC plus B bar C using the Boolean laws. Okay. So mostly here I am going to discuss about the how to solve the Boolean laws. So here first write down the given equation. F is equal to A bar BC plus ABC plus B bar C. So A bar BC. So first find out the common terms. So in between these two, BC it is the common. Okay. If I take the A bar plus A common, I'll get the A bar plus A is equal to 1. Okay. And remaining thing write as it is. Okay. So A bar plus A all know as the OR law. Sorry, this is one law. A plus A bar it is 1. So BC plus B bar C again, take the C as the common term. Again B plus B bar it is equal to 1. So F is equal to C. Okay. So final answer will be F is equal to C. Okay. So here I have completed the part B of this question paper. So if you have any queries among these questions, among these whichever I told you, just comment on this, and for more question paper, whichever you want the topic to be I taught or clear your concept, just comment it. So for my videos, just like and subscribe it. Okay. Thank you for watching my videos.
वीडियोस बनाने हैं फिल्मोरा है ना।